So we know that there is biology, that there are microorganisms living on the surface of glaciers and ice sheets, under them, within them.
The Black and Bloom project's a big project looking at Greenland ice sheet melt rates, specifically resulting from black carbon and algal blooms, hence Black and Bloom.
So I work with the atmosphere. Air circulates around the planet and we're all polluting each other all of the time. I always say to people, think about the atmosphere as like a cooking pot. They put all the ingredients in, and these ingredients can be black carbon, or soot as people commonly call it.
Jason Barks and Marek Stabal of the Dark Snow project, for example, have been looking into this in the last couple of years.
The period of record, which is only 15 years, there's been a strong increase in fire. The fires in the last 3 years have been burning at an intensity twice what they were in the early part of that record.
And all these surface impurities that you can see down here, this is mineral dust and soot and algae, and this is darkening the surface and causing it to absorb more energy and accelerate the melting of the ice.
So now you've got your ingredients and you've got the cooker, and then inevitably they will come down to the surface.
This super dark material is called cryoconite, and it's made up of dust, algae, black carbon from wildfire and industrial sources, and pollen, sea salt, and other material like that. You find this all over the lower elevations of the Greenland ice sheet. Because it's so dark, wherever it lands and collects, it absorbs more sunlight and increases melting.
So over here we've got a patch of very clean, very highly weathered ice, this white patch here. A lot of light is being reflected back off that surface. Around it there's an area with a lot of impurities, a lot of dust, soot and algae, which is, you can see it's darker. And down here we've got an area that's also visibly darker, but largely because of the pooling of meltwater. And those are really three of the major controls on how much light is being bounced back off the surface, and alternatively how much is being used to melt the ice.
A lot of the particles and a lot of the contaminants, if you like, on the ice sheet that are darkening the ice sheet, they're actually algae.
So algae growing on the very ice surface, and these algae produce this very dark pigment. They are the most important factor for darkening the surface.
We've been correlating the measurements that we've been doing on how dark the snow is with these cell counts, and we're getting really good correlations.
What seems to have happened with the ice algae is that they develop other pigments that aren't used in photosynthesis, and these protect specifically against UV as well, so it's a very high UV environment.
These rod-shaped dark areas, that's a single cell, and inside that it's packed with protective pigments which cause it to be dark, and it's that's actually causing the ice to darken.
It looks like the growth of algae in this area of the ice sheet can have an impact on the albedo, or the reflectivity of the ice sheet, on the order of 20 to 30% potentially.
The argument is that there is life wherever there is liquid water.
The process of melting and increased melting on the ice sheet generates more liquid water in larger areas and for longer times.
Bacteria, as every living organism, need liquid water to survive. So if there is more water, potentially there is more bacterial growth.
And that can create a positive feedback because it provides more living space for the algae, and they will obviously further darken the surface, which will then generate more melt.
This is another factor that until now has been overlooked, really. So it's a hugely important aspect to bring into the equation of how these environments, these very climate sensitive environments, are changing in front of our eyes at the moment.